For example, when we consider about our document we discussed in our last chapter, so about author, about title, about date of publication. So normally we have a document. So this document giving information about this document. For example, in a particular document, we will be checking again details about the document. So what is the author of the who is the author of the document, who is the author of the book, what is the title of the document, what is the date of the publication, like this. So we are getting information about the information, that is metadata. So in this we term as the specific forms of data about a document. For example, its author, the title of the document, and date of publication of the document. That is called metadata. So this metadata, you can see here, this metadata, they will include fields. So fields in the sense this is date of creation or format of the document. What is the date of the creation? What is the format of the document? And it can also be the title of the document. It can also be title of the document. So these are called fields. So fields, when we say fields, so this can be date of creation, format of the document, and it can also be the title of the document. One second. Okay, it can also be the title of the document. So uh, here another one, parametric index. So parametric index, there will be one parametric index for each field. There will be one parametric index for each field. Okay. So for date of creation, there will be one parametric index which will allow us to select only the documents matching a text specific in the query, specified in the query. So date of creation, as I told you, date of creation, it can be fields. So fields in the sense here giving some information about that particular document. Okay. So we will see example. First, let us just go through this and we will see the example. What is parametric index? What is Jones? What is fields? What is metadata? So now coming to Jones, Jones are also similar to fields. For example, in Jones, we have this can be arbitrary free text, arbitrary free text. So whereas a field may take only one relatively small set of values. So field, it will have some small set of values, and a John, it can be a set of arbitrary unbounded amount of text. So you can see the difference here. A field, it is some small set of values, and a John, it is uh, unbounded amount of text. It can have unbounded amount of text. Here they are giving some example. Document titles and abstracts. Document titles and abstracts are generally treated as Johns. So we will see here. So you can see the example, parametric search. Parametric search. So author, title, date of publication. Then you can also have language, project type, subject group, sorted by date of publication. So date of publication you can see here. So these are known as fields. Okay, these are known as fields. And uh, this is a parametric index. Okay, parametric index where we perform parametric search. So parametric search, in this example, we have a collection with fields allowing us to select publications by Jones, such as author, and fields such as language. So author, This is example of John and uh, fields such as language. So for language, this is known as fields. So one more example you can see here. The basic John index. Johns are encoded as extensions of dictionary entries. Johns are encoded as extensions of dictionary entries. So this is known as a John index. So we have William.abstract, William.title, William.author. So this kind of where we represent the index, this is known as John index. So John index is useful for an efficient computation of scores. So the calculation of scores using this technique is known as weighted John scoring. So these are similar with the previous inverted file where we have posting list here. Okay, 11 is nothing but the location where this particular word belongs. So for example, abstract. So William is the document. So abstract is your term. So William dot abstract. That means in that particular document, the term abstract is there in location 11. That is your posting file, posting list. And William the abstract, it is also there in 121, location 121, and so on. For same for title also, we have William the title, it is in location 2, 4, 8, and 16. William the author, this is also same. The location of author is in 2, 3, 5, and 8. And the second one, here, the John is encoded in the postings rather than in the dictionary. Here, this John abstract title William, it is encoded in the dictionary, in the term itself. So we consider in the term itself. Here, we consider the John in the posting list. So here you can see 2 is encoded along with author. 2 is encoded along with title. That means same here, title it is there in location 2, author it is there in location 2. Similarly, John is encoded here in the postings. Posting means the location 2 2. Author, the John author, it is there in location 2. Title, it is there in location 2. Author, it is there in location 3. So you can see the two differences here. In the first one, Johns are encoded as extensions of dictionary entries. So this left side where you can see William.abstract is normally we put the dictionary, right? So this left side is also is known as dictionary, right side is known as postings file. So the Johns are encoded as extensions of dictionary entries. So in the dictionary entries, we have encoded the Johns. Whereas in the second example, we have encoded the Johns in our posting file. Okay, in our posting file rather than encoding in the dictionary entries. Okay. So next one we shall see what is weighted John scoring. Given a Boolean query Q, so we have a query Q and a document D. We have a query Q and a document D. Weighted John scoring assigns to the pair query and document. So we make a pair query document a score in the interval 0 to 1. A score in the interval 0 to 1 by computing a linear combination of John scores, where each John of the document contributes a Boolean value. Okay, so let us see how it is contributed a Boolean value. So we consider, for example, this concept is same with Boolean retrieval. So when a particular term is there in the document, we represent by 1. When the particular term is not there in the document, we represent by 0. The same concept we are using here, and we are going to calculate the scores. So weighted John scores. So consider a set of documents, each of which has L Johns. Suppose if the document has L number of Johns, then let G1, G2 and so on up to GL. It belongs to 0 and 1. It belongs to 0 and 1 such that summation of I goes from 1 to L, Gi equal to 1. Gi equal to 1. For this value 1 less than or equal to I less than or equal to L, let Si be the Boolean score denoting a match. A match means if the term is present or not. If it is present, we are going to represent by 1. If it is not present, so absence of the term, then we are going to represent by 0. So the Boolean score from a zone could be 1 if the query term occurs in that zone. So this is 1. So that zone value, zone term is represented by 1 when all the query terms occur in that zone, otherwise it is 0. So the same concept which I have already taught in Boolean retrieval. So if it is present in the zone, here we are going to represent by 1. If it is not present, we are going to represent by 0. So the final weighted zone score we define by summation I goes 1 to L, Gi and Si. So let us see the example. Okay, so we have been considering about the same example, Caesar, Brutus, the same example. That example, we have taken it from a document by Shakespeare. So let us consider the query author, title, and Shakespeare body. The Boolean score function of a zone in the collection in which its document takes on the value 1, the query term Shakespeare is present in the zone and otherwise 0. So we consider the query author, title and Shakespeare. So weighted zone scoring in such a collection would require 3 weights. So G1, G2, G3. These are weights. So for author it is G1, for title it is G2 and for body it is G3. For title, author it is G1, title it is G2 and for body it is G3. So these are the 3 zones we have. Okay. Author, title and body are the 3 zones we have, and for each zones we have associated some weights for G1 for author, title for G2 and for G3 body. Suppose we get G1, if the weight randomly assigned for G1 is 0.2 and for G2 is 0.3 and for G3 is 0.5. So then why we make this value in order to make the summation of these 3 weights equal to 1. Okay. So we will see here. So if the term Shakespeare were to appear in the title and the body zones, but not in the author zone of the document, the score of this document would be 0.8. How? Let us see here. So we are going to see the term Shakespeare if it is present in the 3 zones. So Shakespeare, considering Shakespeare is present in title and body zones and not in the author zone. Considering if the term Shakespeare is present in title and body Jones, whereas it is not present in the author John. Then the score of the document would be zero point 0.8. How? The calculation is here. So by formula, the weighted Jones score is given by summation I goes L to 1. I goes from 1 to L, Gi and Si. So Gi weight is for, the first one is for author. For author, it is zero point 0.2. So G1 is zero point 0.2. You can see here G1 is zero point 0.2. G1 is associated with author. So for author G1, the weight is zero point 0.2 and Si is 0. It is represented by 0. The score is represented by 0 because Shakespeare term is not present in the author John. Shakespeare term is not present in the author John by question. From the question, we know that Shakespeare term is not present in the author John. And now we have second value G2. This is G2. This is G1. This is G2 and this is G3. So G2 0.3 is coming. You can see from here G2 0.3. G2 is associated title with title John. So for title John it is 0.3. So you can see 0.3 here. The score is 1 because from the question we consider that the term Shakespeare is appearing in title and body Johns. In title and body Johns. So for title, it is zero point 0.3. Since the term is present, it will be 0, it will be 1. If the title is not present, if the term is not present, it will be 0. Since the title is not present, the Shakespeare term is not present in the author John, we put 0 here. Again, the Shakespeare term is present in the title John, that's why we put 1 here. And 0.3 is nothing but the weight associated with title John. And finally, finally, for Shakespeare term, it is present in the body John, so the score is 1. And the weight associated with the body John is 0.5. So G3 0.5. So now we get 0.2 G1 into S1. S1 is 0, score 1 is 0 because Shakespeare is not present in author John. G3 is 0, G2 is 0.3 into S2. S2 is 1 because Shakespeare term is present in the title John. And finally G3. G3 is 0.5 into 1. 1 is S3. S3 is nothing but the score for Shakespeare in the body John. So in body John, since Shakespeare is present, score 3 will be 1. So when you do the computation for this, we got 0.8. So that is what 0.8. So once again, let me explain this from the beginning. So we have some scoring parameters here. You can just go through what is metadata, what is fill, what is Jones. And Jones and fills are somewhat similar. Fills will have small set of values, whereas Jones will have unbounded amount of text. Okay. And we normally consider titles, abstracts, authors, they are treated as Jones. Whereas in fields, date of publication, date of creation, the format, these are considered as fields. And for Jones, we consider titles, abstracts, and body. Body can have unbounded amount of text. Abstracts can have more amount of text. Titles can have more amount of text. Whereas in fields, we can have some only set of small values. So for example, date of creation, it will contain only the date. Month of creation, it will contain only the month. Date of publication, it will contain only some few parameters, right? So fields will have relatively small set of values, whereas zones, it can have unbounded amount of text. And we have two things for basic zone index and zone index. In basic zone index, we have uh, the zones are encoded along with the dictionary. And in the second figure, you can see the zones are encoded along with the postings. So either way, you can represent the index. And weighted zone scoring, this is similar with Boolean retrieval. Here, instead of representing the term Boolean representation, we do here using the score. Using the score so that we can calculate weighted zone score values. So using this formula, summation I equals 1 to LGISI, what we can do is G1 is nothing but the weights associated with the zones, and S1 is SI is also the scores associated with the zones. So let us see the example. We are going to check the Shakespeare term if it is present in uh, author, title, and body zones. Suppose we are going to calculate the weighted zone scoring for Shakespeare term using the zones author, title, and body. So normally what we are going to do is there will be three weights G1, G2, G3 associated with the zones. So we had three zones for this particular example. So there will be three weights. And what you have to do is all the three weight summation value will be equal to 1. So the weights are randomly generated. So we have G1 for taking an example, G1 0.2, G2 0.3, and G3 0.5. We are going to calculate the weighted zone score for Shakespeare. And we have to considering that Shakespeare is present in title and body and not in author. Shakespeare is present in title and body zones and not in author zone. Then consider the query. So this Shakespeare, 1 second. Okay. Now, so you can see here we are considering Shakespeare is present in title and body zones, whereas it is not present in author zone. So we substitute the values. G1 is 0.2, S1 is 0 because S1 is associated with author, and the score for Shakespeare in author zone is 0 because Shakespeare is not present in the author zone. Now G2 is 0.3 and S2 is 1. Why? Because Shakespeare is present in the title zone. And similarly, G3 is 0.5 and S3 score 3 is 1. Again 1 because Shakespeare is present in the body zone. So by computing, we got 0.8. The weighted zone score for Shakespeare in the given zones is 0.8. Now coming to term frequency and weighting. Term frequency and weighting, how we are going to do this one is, here we will be computing a score between a query term T and a document D. Query term T and a document T. Document D. Okay. So based on the weight of T in D, so we will be calculating term frequency. So as you already know what is term frequency, right? The term frequency means the number of terms in the document. The number of terms in the document. That means total number of occurrences of the particular term. Now, this weighting scheme we refer to as term frequency and it is denoted by TFTD, term frequency for the term in the document. This one. T is term, F is frequency, term frequency. Okay. And TD you are having here, this is for the term in the document. You have to read like this. Okay. The term frequency for the term in the document. So now inverse document frequency. Inverse document frequency. We have collection frequency, we have document frequency. So for collection frequency, it is defined as the total number of the occurrences of a term in the collection. In the whole collection. Again, this is for the whole collection. Total number of occurrences of the term in the collection. Whereas document frequency for the term. That means define the number of documents. So this has been already explained in the earlier chapters also. And here we are going to count the number of documents, not the number of terms. Okay. In document frequency, we are going to count the number of documents where that particular term is containing and not the number of terms. Number of documents in the collection that contain a term D. So denoting the total number of documents in the collection by n, and the total number of documents in the collection is denoted by n. So inverse document frequency is given by this formula. IDFT, inverse document frequency for the term, it is equal to log n by DFT, document frequency. So you have to know this formula very carefully. Otherwise, when you calculate this, you will be getting wrong results. Here it is DFT, document frequency. You have to remember the denominator here is document frequency, not the term frequency. Okay, document frequency, number of documents in the collection that contain that particular term. N is nothing but total number of documents for the collection. So by computing this, we get inverse document frequency. Inverse document frequency. So let us see some small examples to calculate inverse document frequency. So IDFT. Before that IDFT, it is term frequency and inverse document frequency weighting. Term frequency and inverse document frequency weighting. So inverse document frequency, this is given by this formula. Here, just we need to multiply the term frequency and inverse document frequency. Term frequency for the term in the document into inverse document frequency for the term. So these two, when you multiply, you get TF IDF. TF IDF weighting. And the example down given here is for calculating inverse document frequency. So how inverse document frequency is calculated? For this particular example, you can consider would give 806,791 documents, that is N capital N value. So capital N for this particular example is 806,791. Inverse document frequency for this particular example, we consider N equal to 806,791. And these are the document frequencies. Document frequencies are already given in this. Just you need to compute using the formula. You just compute this and check it whether you get 1.65 for car and for auto 67 to 2.06. You can just check it like this. IDF in suffix you write car equal to log n divided by document frequency. So log n directly I will write 806,791 divided by DFT. This is 18,165. Check it whether you get the values. So give me just 2 seconds, okay? Did you check it?
Yes, ma'am.
You got the answer?
Yes, ma'am.
Okay. So like this, here directly the document frequency is given. Okay. So in exam, what we are going to do is we will be giving some set of documents. For example, actually this would be written in suffix. Okay. Mm, suffix. I don't know where is the option. Like this, it should be written in the suffix. Okay. IDF. This is small I. Inverse document frequency for the term car. Okay. Like this, you have to calculate for auto, insurance, and best. And what I am trying to say here is, in this particular example, we have already given along with the document frequency values. But in exam, there will be a question given like this. Last time, say B1, some terms will be written like this. B2, B2 also, some terms will be, array yaar, what happened? Okay, anyway, here this is the image, so it's all covering up. So D1, D2, D3, it will be given like this, and from this you have to count uh, N, capital N. What is the N value you have to count, and what is the DFT you have to count. Okay, so next slide we will see some examples on it so that you can understand it. So this is how we find inverse document frequency. Now score, finding the score for this document. So the score of a document D is the sum over all query terms, So the score for the query in the document is given like this. Summation T belongs to Q, term belongs to the query, term frequency, and IDF. So summation of ITF, IDF. So TF, IDF, you know how to find, right? TF, IDF, it is given here. TF, IDF, it is given by this formula. Summation of term frequency and inverse document frequency. So when you find score, you just need to do the summation of term frequency and inverse document frequency values. So TF, IDF value, you have to do a summation. So an example is given. This is the TF values. So for car, the TF value, term frequency in document 1 is 27. Term frequency in document, this is term frequency. Okay, term frequency. One table is given here. So, and along with this table, when you if you want to find TF IDF, then what you have to do, you have to multiply along with this 1.65. So let us do one example here. Suppose considering this example, mm, so TF IDF, okay, TF IDF, TF IDF for car. I'm just writing like this. Equal to the TF for document D1. D1, the TF is 27. 27 into the IDF value is what? 1.65. 1.65. So this is for first TF IDF for document D1. This is for car in D1. Okay. Now, similarly, TF IDF for car in D2. So for this one, it is 4 into 4 into 1.65. And lastly, TF IDF for car in D3. It is how much? 24 into 1.65. Okay, so we have this. Now, if you want to find the score, how will you find score for the query in the document? For the query in the document is summation of all these values. Summation of all these TF-IDF values. So directly you can write 27 into 1.65 plus. You can write this value and plus. Sorry, uh, like this. Okay. So this gives the score value for this particular term car. Similarly, you can find for auto, you can find for insurance, you can find for best. So this is nothing but score for the query in the document. So here we add up not only the number of occurrences for each term in D, but instead we are going to add the TF-IDF weight of each term in the document. We are going to add TF-IDF of each term in the document. So TF-IDF for D1, TF-IDF for D2, TF-IDF of D3. You do a summation and you will get the score for that particular term. Okay, so this is how we find your TF-IDF. So, okay, for example purpose, I'm just putting this. So you can update in your notes. Notes I have already sent you. There, this example solving is not there. You can just update in your material. Okay. Now coming to next one, the vector space
Ma'am,
model. Yes.
ma'am, just wanted to say that our next class, uh, the 12 o'clock class will be, our teacher has asked us to join by 11:55.
By 11.
No, by 11:55. Uh, I'm just saying that it might get a little late if we
Yeah, yeah, yeah,
continue.
yeah. No, no.
Mm,
She said she will be starting by 12, so you can just join at 12. Okay. Let me
Okay,
just
ma'am.
finish. Only one more slide is left before we uh, finish this
Okay,
one,
ma'am.
and I will take a quick roll call, and you can just leave the class. Okay. So vector space model for scoring, and here there is a big calculation, but before that calculation you just need to know this part. Okay, so the representation of set of documents as vectors in a common vector space is known as vector space model. So representation of document as vectors in a vector space, it is known as vector space model. So this is a real chapter. So before this chapter, we just need to know all this metadata, joins, fields, examples, score, finding this one, IDF, TF, IDF. So after knowing this only, we can start vector space model. Otherwise, we cannot start vector space model. In vector space model, we represent set of documents as vectors. So we have two formulas here. One is cosine similarity formula. So cosine similarity formula is given by similarity of document, the two documents. Okay, you just see here. If you want to find the similarity between two documents D1 and D2, then you have to compute the cosine similarity of their vector representations. vector representation of D1, vector representation of D2. The cosine similarity, it is given by vector dot product of these two vectors and absolute values of these two values. The numerator represents the dot product of vector representation of D1 and vector representation of D2, and denominator is the Euclidean length. Euclidean length, you have to find Euclidean length of D1, you have to find Euclidean length of D2. So this computation we will do in our next class. Okay, and Euclidean length of that particular document is given by root over summation I goes 1 to m vector representation of the vector square representation of D1. So this is normal length calculation for distance. So we have Euclidean distance, we have absolute distance, we have city block distance, or we have already seen in our last class also. So Euclidean distance is calculated by this formula root over this one vector square of that particular document. So numerator is a dot product, denominator is the Euclidean length. Euclidean length, separately we use another formula to find the Euclidean length. And computing this numerator and denominator, we get cosine similarity between the two documents. Okay. So calculation we will do tomorrow. This cosine similarity calculation we will do tomorrow. So before we wind up, I will take a quick roll call. Okay, roll number one,
Present, ma'am.
roll number two.